Hi class, how are you? Hope you're doing well. Today we're going to cover simple regression, which is a form of regression where you have only one independent variable or predictor. It's simple but quite powerful. We're first going to talk about what regression is and then the assumptions that go with it. We'll then look at its application in RStudio, how to run it, and so forth. And then we'll conclude by looking at interpretation. There's a lot packed into this lecture, so hold on to your seats and let's get started. So let's take a look at what regression is. Regression describes the relationship between two or more variables, and we will focus on linear regression. We're looking for one continuous DV, or the outcome variable, plus one IV, or independent variable, which is the case of simple regression, which is what we're going to focus on today. If you have two or more IVs, then you will have multiple regression. And regression can be used for prediction purposes. And so if you know the IV, then you can predict the DV. And so that's the beauty of regression, is that there is prediction involved. And so you can use the regression results to estimate what might happen between those two variables, even if you don't have all the data points. So let's talk a bit about the regression equation. And so in simple regression, where you have one IV and one DV, you can express the relationship as y equals bx plus a. You might recognize this from algebra. Y is the outcome variable score. X is the predictor score. B is the slope of the regression line. And then a is the intercept, so the value that y would take on if x happened to be 0. And so this is nicely illustrated by this diagram. And so that's the regression equation. Now in reality though, your data points will most likely not line up in a perfect little line. So it might look something like this, where the data points are kind of scattered around the regression equation. So what do you do then? Well, you use some sort of a method to estimate the regression line that has the best fits the data. The ordinary least squares method is pretty commonly used, and what it does is that it minimizes the squared distance between your data points and the regression line. And so if you think about the distance that a data point might have with a regression line, something like this, then you want to minimize that difference squared. And so here's another way to take a look at it. And so again, you have the difference between your actual data and the predicted value of y, which is shown on the regression line. And you minimize that distance squared for the entire data set. And so translating that to the regression equation, then you would get something like this, where the b, or the slope, would be estimated like this, and a, or the intercept, would be estimated like this. So let's break this down a little bit. So y hat is the variable that represents the predicted y. And so that's essentially just saying the predicted outcome. The epsilon in the equation is the error or the residual term. And it's a theoretical term. It never really appears numerically, but it's a theoretical term that captures the difference between your actual data values and the predicted values. So it's essentially an error term. Looking down at the slope, or the b coefficient, let's take a look at the numerator. The numerator is the sum of the products of the deviations from the mean. Now, that's just a mouthful and a fancy way of saying that you take each data point and from its coordinates, subtract the mean of x and mean of y correspondingly, and then you make a product. So you multiply those differences for x and y, and you do that for each point and sum it all up. That's a fancy way of saying that. And then the denominator is the sum of squares, where you take the deviation from the mean for the x, and then square that and sum it all up for all your data points. And so that's it. And then the intercept is y bar minus the slope times x bar, which is really saying the mean of y minus the slope times the mean of x. Pretty easy. So that's what the regression equation is showing you. Now that was super beautiful, but it's time to talk about assumptions that go with regression. And so here are some assumptions that you want to meet for regression in order to get reliable results. And I've grayed out the fifth one because that pertains to multiple regression, which we're not going to cover in this course. But we can talk about the first four. So breaking down the 4 assumptions, you already know how to check the first one, which is that variables are normally distributed. Hooray! And then you can also pretty easily check to see if your variables have a linear relationship by using the scatter plot or the plot function. So we'll cover that during lecture. And then a couple more things that you can check after you run the regression. So residuals are normally distributed, and also that there's homoscedasticity. We'll cover what these 2 assumptions mean when we get there. And so let's start talking about the application of these principles and running regressions in our studio. And so for this lecture, for simplicity, we're going to continue working with the mindfulness dataset. Now there's a regression version for you to save on Canvas. And let's say that you had a research question. I'm going to give you 2 versions of it. One of them is non-directional. And so you might say something along the lines of, does mindful awareness of one's present experiences, so the variable awareness, predict perceived stress, the variable stress? And so notice that it's asking a question about prediction, but it doesn't state in what direction. Is it going to be a positive relationship or prediction or negative? There's no statement of direction. It just asks whether awareness predicts perceived stress. What about a directional research question? Does mindful awareness of one's present experiences positively predict perceived stress? And so let's say that the researcher has a reason to believe that this relationship would be positive. So the greater your level of awareness of your experience may be, the greater your perceived stress because you're more aware of your stress responses in your body. Or perhaps the researcher has studied this before and has found that there's a positive relationship between these 2 constructs. Regardless, notice that the research question asks positively predict, and so it states a direction of the relationship. Now let's translate these into hypotheses. So here's a non-directional version. So the null hypothesis might say awareness does not predict perceived stress, whereas the alternate hypothesis would say awareness significantly predicts perceived stress. And if you translate that to notation, beta is your population regression coefficient. And so the alternate hypothesis would say that beta is not equal to 0, that there's a significant relationship, but it could be in either direction, positive or negative. Whereas null hypothesis would say that the population regression coefficient, or beta, is basically equal to 0, and so there is no relationship. How about the directional hypotheses? So in this instance, the null hypothesis would say awareness does not positively predict perceived stress, whereas the alternate hypothesis would say awareness positively predicts perceived stress. So once again, they're opposites of each other. Translate that to population regression coefficient. So the alternate hypothesis would say that the population regression coefficient is going to be positive. It's going to be greater than 0. Whereas the null hypothesis says the opposite, that it's going to be either equal to or less than 0. Now, in most instances of regression, I think researchers tend to have a directional research question and hypotheses. Usually when you're thinking about whether your IV predicts DV, you have some idea about whether that relationship is going to be positive or negative. And so in this instance, let's go ahead and run with the directional hypothesis. And so we will go ahead and work with this particular setup in our demo. Now, before we start running the regression itself, something we want to do is to think about assumptions. Have we met all the assumptions, for example? And so in this instance, one of the assumptions that we have not practiced checking is to check to see whether your variables have a linear relationship, IV and DV. And so we can do that by going to our studio and then using the plot function. And so let me meet you at our studio and show you how that works. So here we are in your best friend, our studio. And what I've done is to set up my working environment. So I've set my working directory and then imported and attached my data frame. And so you can see it right here with those 4 variables related to mindfulness constructs and stress and learning. Now we were talking about using the plot function to check whether or not our independent and dependent variables have a linear relationship. And so let's try to take a look at that. What goes in the plot function is actually pretty simple. And so it's just the independent variable and then a dependent variable. And so we can run that. And then you get this plot. And looking at this plot, of course, it's just eyeballing it. but I kind of maybe see a faint positive relationship if I think about kind of like the best fitting line, which regression will allow you to kind of plot basically. And so eyeballing it, I'm not seeing any evidence that there is like a curvilinear relationship, for example, a quadratic one, which would be shaped like a U, like upside down U or a positive U kind of a thing. It looks fairly linear to me. And so that was a quick and easy way to check that second assumption about the potential linear relationship. If you see this type of scatter plot and you see a curvilinear relationship, then you will probably want to think about whether you want to use linear regression. Now you've done a great job setting the stage for running and interpreting regression analyses. And so how about a little break? And so this is a good time to pause, review, answer some review questions, and stretch. Take some deep breaths before we jump into part 2, where we'll be running analyses and interpreting those. And it's going to get pretty busy, so go ahead and recharge, and I'll see you back in part 2. Talk to you soon.